Hello everyone, you are welcome. Today we have a new beautiful geometry math problem. Let's say we have given a right trapezium whose two sides length are given. This side is 5 units and this side is 10 units. And there is a circle inside the right trapezium. Our target is to find out the area of this circle. Now how can we solve this beautiful geometry math problem? First of all, let us suppose this is our figure trapezium A, B, C, D. Let us suppose this is the center of this circle, and let us suppose this is the point P, this is point Q, and this is point S, where the circle touches the right trapezium. So first of all, here we will connect this center with point P, Q, and S. So this figure will become, let us connect this. Also connect center with point S. Now this is the radius of this circle. So here let us suppose this radius is equal to x. Now this OQ is radius, so OP is also radius, so this will be also x. This will be also x. Now as we know that at the point of tangency, the tangent line is always perpendicular to the radius of the circle. So here there will be a right angle triangle at both sides of point Q, and there will be also a right angle, and there will be also, now this side is x and this side is also x, so their opposite side will be also x. This will be x and this will be x, this will be x and this will be x. Now what we'll do here, look to this side of this right trapezium. This is AB is 5 units, but this AQ is x units. So what will be the remaining length QB? The remaining length will be 5 minus x units. Look to this one side, this one base. This DC is 10 units, but D is x units. What will be the remaining length? This length will be 10 minus x. So here is C is 10 minus x. Here our target is to find out the area of this circle. Now the area of circle is pi r square, where r is the radius. So here our radius is x. So here our target is to find out the value of x. To find out the value of x, first of all, here we will draw a perpendicular from this one point B to this side DC. So this figure will become, let us suppose this is point E. Now here we will try to find out the value of x using this right angle triangle. Now what will be the length of this side, and this side of this right angle triangle? Look to this side, which is opposite to this one, diameter of the circle. Now this is x, this is also x. So this BE will be 2x. What will be the length of this EC? Here this total length DC is 10 units, but this length AB is 5 units. So this DE will be also 5 units. Now 10 minus 5 is 5. So this EC will be 5 units. What will be the length of this BC? Now to find out the length of this BC, here we will use tangents to a circle theorem. That is, if we have two tangents from an external point to a circle, then the length of that tangents will be equal, same, congruent. So here from point C we have two tangents to this circle, SC, and let us suppose this is point F. The second tangent is FC. Here this length SC is 10 minus x. So this length FC will be also 10 minus x. Now we have also two tangents from point B to this circle, tangent BQ and BF. Here BQ is 5 minus x, so this BF will be also 5 minus x. What will be this total length BC? This will be 5 minus x plus 10 minus x. So adding these two numbers, it gives him about 5 and 10, this is 15 minus 2x. So here the length of this BC is 15 minus 2x. So here we have the three-sided length of this right angle triangle. Perpendicular is 2x, base is 5, and hypotenuse is 15 minus 2x. So here in this right angle triangle we will apply the Pythagoras theorem and we will find out the value of x. So by Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. So this will become, here our hypotenuse is 15 minus 2x whole square. Base is 5, so it will become 5 square plus perpendicular is 2x, so this will become 2x whole square. Here we will expand this left hand side using a minus b whole square identity. So here we will expand this using this one identity. A minus b whole square is equal to a square plus b square minus 2 times ab. So this will become 15 square plus 2x whole square minus 2 times 15 times 2x. Now 2 times 15 is 30, 30 times 2 is 60. So this will become 60x is equal to 5 square, simply 25. This is plus 2x whole square. Now look at to both sides, there is 2x whole square, so we will cancel them with each other because they have the same sign. So here we will move this number 25 to the left hand side and this negative 60x to the right hand side. So this will become 15 square is simply 225 minus 25 is equal to 60x. Now we will simplify this left hand side, so it gives him simply 200 is equal to 60x. Now we will divide both sides by 60. This 60 and this 60 will be cancelled. Now here these two numbers are divisible by 10, so 10 times 6 is 60 and 10 times 20 is 200. Now these two numbers are divisible by 2 further, so this is 3 times 2 is 6 and 10 times 2 is 20. So here the value of x will become, this is 10 by 3. So here x is equal to 10 by 3 is the value of x and the radius of this circle. So here this value of x is 10 by 3. Now we will come to the area of this circle. Now the area of any circle is pi r square. So therefore this area will become area of circle is equal to pi r square. But here our r is x, so we will substitute the value of x. This will become 5. R is 10 by 3 whole square. So this will become pi times, here 10 square is simply 100 and 3 square is 9. So the area of the circle will become, this will become 105 divided by 9. And here if we substitute the value of pi, which is 3.1415 up to 4 decimal places, so this number will become, it will be about 35 square units. So finally our area and our required target is 35 units square. So here the area of this circle in this right trapezium is 35 square units, which is our final answer. And last, don't forget to subscribe my YouTube channel for such a more interesting and step-by-step geometry math problems. Thanks for watching.